Hello everyone, welcome back to our rearrangement series part 6. Today we are going to study Hofmann versus Curtius versus Lossen rearrangement reactions. So let us see who wins the nitrogen game. Stay tuned with ChemONotes. Grab your notebook, and those students who have not seen our previous videos part 5 and part 4 where we have already discussed Hofmann and Curtius rearrangement reactions, please go and visit the playlist of rearrangement series. So let's begin. So today we will be studying these three rearrangement reactions, that is Hofmann, Curtius and Lossen. All three rearrangement reactions have some similarity and they give similar product. Okay, so Hofmann Curtius rearrangements are related with what? Converting carboxylic acid into isocyanates, and all are going to convert into the amines or other products which are similar to amines. So Hofmann involves amide, Curtius involves acyl azide, and Lossen involves hydroxymate ester. So let us see what is the similarity of all these three rearrangement reactions. So in your CSIR NET exam, they ask the options may be given and they will ask which is the starting material or which may be the reagents which are used. So it can be asked in any way. But let me tell you, all these three rearrangement reaction gives us amines. Okay. So Hofmann rearrangement reaction, primary amide is converted into isocyanate. Similarly, carboxylic acid of Curtius will first get converted into acyl halide and then converted into isocyanate. Similarly, Lawson's rearrangement, the hydroxymate ester gets converted into isocyanate and then converts into amine. So let us see. Now, first of all, those students who have not seen these reactions or the videos of Hofmann and Curtius, which I have already prepared in detail, and we have solved many examples based on Hofmann rearrangement and Curtius rearrangement. Please go and visit this link, which you can see here. Okay, go and see the link, or you can even visit the ChemONotes playlist where you can find the videos in details. So let's begin. Hofmann rearrangement, aqueous NaOH or KOH we take in the presence of bromine, which will convert the rearrangement. It will take place. The R group will rearrange itself to give isocyanate, and you will find that NH2 group will be that is, there is a rearrangement taking place. This R groups rearranges itself to the nitrogen. Here you can see here. So this already I have told it in my previous videos in detail. So let us see. So there is a elimination of carbon dioxide gas and it gets converted, isocyanate gets converted into primary amine, that is RNH2. Similarly, in Curtius rearrangement, you can find here that when it reacts with sodium azide, okay, your carboxylic acid gets first converted into acyl halide and then it gets converted into isocyanate. So then the same reaction takes place when water molecule is going to get added on carbon nitrogen double bond. Carbon dioxide gas will be released and it forms a primary amine. Similarly, in Lawson rearrangement, you will find that there is a leaving group which gets removed. Okay, it is eliminated because of the base, and there is rearrangement of the R group to form isocyanate. And if you try to compare all these three reactions or the rearrangement reaction, you will find that in all the three rearrangement reaction, even though the starting materials are different and the reagents used are different, but ultimately the intermediate you will be getting is isocyanate, and the final products may be urea, amines, okay, such type of or derivatives of amines we can see. We are going to get the products. So let us see one example. So Hofmann rearrangement, your benzamide, that is PH, C double bond O, NH2, when reacts with aqueous NaOH or KOH in the presence of bromine, there is a formation of isocyanate. Okay, the phenyl ring gets rearranged towards nitrogen. In detail, the mechanism I have shown in my previous videos. Okay, how the rearrangement takes place, how the bromine is getting added to the nitrogen and all those things. You can go and visit that video and see those videos. Next, now the next thing is what? Your water molecule is going to get added on nitrogen and carbon dioxide gas will be released, and ultimately we will be getting pH NH2. Okay, that is, it will be forming a amine here. Even this we can write it in this way, that is, we can show it a phenyl ring. Okay, and that phenyl ring, there is a amine, so it is a aniline which is going to be formed. Okay, there is a formation of aniline, NH2. So benzamide has been converted into aniline. Similarly, in Curtius rearrangement, acetic acid when reacts with sodium azide, it gets converted into isocyanate, and the same reaction takes place. Okay, water molecule gets added on nitrogen, double bond carbon, and there is elimination of carbon dioxide, and ultimately you will be getting the product, that is CH3 NH2, that is. So here you will be, we are going to get a methylamine. Okay, this is your methylamine, whereas the previous one we have got aniline. And the last one is Lossen's rearrangement. There is a hydroxymate ester. So this is a living group which will be removed by rearrangement of the ethyl group, and we will be getting a isocyanate, and ultimately the same further mechanism takes place, and you are going to get C2H5, okay, NH2, that is amine, ethylamine, ethylamine. And this way, see, in the exams they may ask you that they can give the options below, Hofmann, Curtius and Lossen, and there may be one more reaction, which of them is not having the same intermediate, they can ask. Okay, so you should remember that Hofmann, Curtius and Lossen all are having the same intermediate, that is isocyanate, and all of them give the final product either the amines or amine derivatives. Okay, student, so this is all for today. Stay tuned with, so thank you for watching. Stay tuned with ChemONotes. You can watch the playlist of rearrangement series. Part 1, Part 2, Part 3 and Part 5 is already uploaded. Further also you can find the other rearrangement reactions which I am going to prepare. So stay tuned with ChemONotes, and please like, subscribe and hit the bell icon for further more notifications. Thank you for watching.